Good evening, everyone. Sorry I'm about 3 minutes late. It's been a rough day today. So let me get set up the right way here. And the first thing we'll do is we'll go over our last week's stream. Okay, so last week's stream I was trying to get a new level and a tile set together. I did that with a I was able to get the actual Turrican tile set working. I kind of made it a lot smaller than what it was. So if we take a look here, now if we go into tile sets, I was able to knock it down from like 100 kilobits to like 43 to get it the right way. And if we look at the bin file, the binary file is the tiles. So here's the tiles. I got it down to 26K. So that is more manageable for the X16. I won't take up all of the video RAM. So I knocked it down to 16 colors, made it a palette, and I resized it into 320 by 200, and that's really it. So what we got out of that is this, which is what we wanted to see, which is essentially, you know, just the level loaded and set to the hard-coded to the starting location we chose in the text file, which is $37.69. And how I came up with that is essentially multiplying 37 by 16 and then 69 by 16 to get the actual tile coordinate, to get the actual pixel coordinate from the tile. So if we move this to the programmer here, I'll show you in the code here where I set the scroll right here. So horizontal scroll is set to O2C0, and if we take 37 and we multiply it by 16, we get 250. However, that came too much. So if we look at hex and we do 2C0, that's 704. And if we take the 704 and we divide that by 16, I used 44 instead to move it over more to the right. So as for the Y coordinate, we did 0130 on the scroll register, and we get that by doing, I think it was 69 by times 16 is 450, right? But if we do 0130, oops, sorry, meant to put it in hex. If we do 130 on that and we divide that by 16, we set the height to actually 19. So our new coordinates is 44x by 19y. So let's correct that in here. So it'll be 44, 19. And let's just make sure that I got that right. We said 130, so we're going to switch that to hex. 130, which is 304 hex. We divide that by the tile size. And we get 19. So that is the XY coordinate on the tile map. So that's where we would pick up the, like if we wanted to do collision with the tile, that's how we would get the tile that we're doing collision with. So looking at what we did here is basically I loaded out. So what was wrong initially was that I needed to put this, the file names include, above all of the other includes, namely the disk one, mainly, I think. So if we look at file name includes, this is where the tiles come from and where the palette comes from and the terrain comes from. So today what I would like to do, according to stream, is I would like to did I click go live? I did. Why isn't this working? Ah, there we go. Perfect. Okay. Sorry. I thought my stream wasn't working. It actually is. It was my phone lagging behind because I got the phone checking out the real stream. Alright, so what we did here was I loaded my palette into palette RAM, I loaded the tiles into our tile RAM, and I loaded the map into the map RAM, which is essentially 0 in VRAM. After that, we initialized the RRQ, which we did over here, which is basically just setting the Vera, looking at the Vera ISR, setting it to 1 if it is set proper, if it's a VSync. So if we look at the Turrican include, the VSync we set to a 0-page address since we're going to be using that a lot. So now the next thing I want to do here today is I want to get the player on the screen. So in order for me to do that, so let's take a look at today's tasks. And we're going to take our start coordinates from last week and move them over here. And today is the 18th. We're doing this primitive right now. When we get more into it, I'll make it more formal. So today we want to do an automatic calling of all the scripts to take care of the converting the assets for me. I want to find a player sprite, a good player sprite to work with. I may have one. I just got to check if it's usable or not, because we need to find one that's, I'm thinking 16 by 32 is going to work for us. Then we're going to need to create some initial player code, like we're going to have to load the player in, and we're going to do all that stuff. Basic joystick processing code, basically to handle all the movement, and we'll get to player animation today. I think if we have time, we'll get to player animation. But I think right now what we're going to do is we're going to, let's see if we can get a Turrican sprite. And let's see if we can we can use one. I found one, and I will put that in with the assets. So we're going to have to do some work with this. So if we look under sprites here, we got Turrican.jpg. I think we found one here. So what I'm going to do is I'm going to try and manipulate this into a sprite sheet in GIMP, and let's see what the sizes are for this. Because I think this should be 16 by 32. Let's double check. So let's go in here, let's open this with the GIMP. Okay, and let's draw a selection rectangle around our sprite. Ooh. Looks like they're damn it. There we go. So 32 by 32. No. We're going to have to rearrange this. This is going to have to come out here. So that would be 25. And this would be 24 by 33. That's not a good thing for the thing. So let's see what the size of this image is. The current size of this image is 382 by 132. So if I change this to 320, 320 by 111, I don't like that. So let's see. If we do 112 divided by 6, no, it should be 32 height. It's 3.5. So we need 32 times 4. It's 128. I think that should scale it right. Ooh, that's not good. Alright, let's deblur this thing. I don't want to just do what I selected. Let's unselect. So we go to select none. Then we'll go to deblur. Sharpen this a bit. These are not going to be the final sprites, so I'm sure we'll find something better. But for now, in order to use this, it's the best I'm going to get. I'll have to find a better sprite sheet. But right now, this is where we are. Okay. So now if we do rectangle selection over this, I'm hoping it's the right. I need this to be 16. So that needs to be 16, and this needs to be 32. I think I'm going to need this to be image scale, image down this to 126. I got the vertical right now. Yeah, the vertical is right. I need to get the horizontal to 60. Let's unhook this. Okay. This is not going to work. Sprites on this are okay. Let's try a different one. Okay, let's see what the size of these sprites are. These are from Super Turrican 2 for the SNES. Found these on Spider's Resource. Holy crap. 32. Okay, so that would be 32 by 32. It's almost good. So let's see how big this image is. Oh, wow. Let's see if I can get this to 320. And let's get this to 240. So that's 16 by 32 right there. Hmm. if I did, this is, no, I don't like that. I don't like that. Let's see. Let's check this one. This is the mobile version. Mobile version of Turrican 3D. Now let's close this, discard, close this, discard. Okay, and let's do a selection here. .32 by 41. How are these people making? They're using just straight bitmaps. Because Amiga can do that. So if I do 30, and it's 32 by 40. So if we go, let's see if we can scale it down. So 254. Let's check the height in at 320. If I take it down another 2 pixels, I might be able to get that. So let's do 318. Let's try 316. I think I got it. So that's So that's 32 by 32. It's actually getting bigger. Let's scale it back to, let's try 324. You know what, let's undo base image. Starting it. And we have this set to 3137. So let's check here. It's the height that's the problem. I can get away with an extra pixel on the height. Cannot get away with the width because the width is well over what I need it to be. So it's 27. So if I go to width 30, 31, 32, it goes into the other image. If I do so that would be 32 by 32. So let's scale the image down to 240 by 320. Well, let's try that. So let's undo this, take this. I need to crunch it down this way. So let's go to 300. Let's see if we can take it in. So I could deal with this. Can I though? So 32 by 32. Let's take the width in a bit. Into the other sprite. Alright, so I can undo that. So we need to make this wider. I think that's it. So there's 32 by 32. The height, I can go a little higher. Let's try 324. No. Alright, let's undo. So we got the width right, now we gotta get the height right. So the height, I did 280 by 280. That is much better. Okay, now let's deblur it. Uh-oh. Let's undo that. That looks like shit. It could be that we're zoomed though. This was pretty bad. What is the... 280 by 280. So let's reload this image. Scale it to 280, 280. And that should be a little bit better. This way I can do, that looks a lot better. All right. Okay. There we go. That's decent to work with. Still not done yet. We're going to replace this sprite. Okay. Alright. So now we need to set it to index mode. Convert it to 16 colors. There we go. Let's take a look at the color palette. That's this one here. Color palette looks good. And we are going to export this. Well, let's save it because I want to make sure we keep the changes here. So let's save that. And then we're going to export it as raw data. Okay, and we are going to call this Turrican Hero Data. So this should export the palette and the data file into the sprites directory. Okay. And as you can see in the sprites directory, we got the data and the palette file. Okay, we're done here. So the next thing is let's convert it. So we're going to go assets, sprites, Turrican Hero.data, and we're going to export that to bin, and we're going to call it hero.sprite. And the mode, and the mode will be 4 bits per pixel on this. Okay, so let's convert. Oh, actually, you know what? I still had more work to do on that. We cannot use the sprite like this. I don't think that's gonna be a good thing. I gotta kind of line this up, so we're gonna figure out how many. I said 280 by 280, and we want this to be 32 by 32. Yeah, that's a 32 by 32 sprite. So I need to knock off I can't knock off a pixel at the top because that's, oh man, I didn't notice that. So this one's all the way up here. This is from a jump. So if we come over this is not 32 by 32 anymore. So this is now, yeah, this is not 32 by 32 anymore. Well, it is, but it's in the wrong spot. I'm going to take out the bottom of his feet if I do that. Damn it. That's not going to be right. So 0, 0 needs to be 32 by 32 there. I really don't know how to do this right. I'm not an artist. Interesting learning experience. Actually, I don't think that's bad. Although this is going to be bad. So if I go to the next one, so if I move this to position 32, 32, 0, that's what I'm going to get for a sprite, and that's going to be, that's not going to be right. So that should be position 0, so 0, 0. So we need to crunch it. Okay, that's better for this. So if we move this over to position 32, I'm going to get the tip of his gun. Still getting the tip of his gun. Looks like I'm going to have to do some copying and pasting. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 frames. Just for I don't like that. Let's check this one. No, I don't want that there. No. Undo. Okay. Let's see this. Damn Amiga sprites. That's no good either. So what we can do is this is going to look funny, but I have a Samus sprite that we can use in the meantime so that I can at least get player movement working. So I have this Samus sprite. So let's see. Okay, Samus should be 16 by 32. And she is. Perfect. So let's take Samus's still sprite. That's good enough for now. Okay, let's create a new image. The size is going to be, width is going to be, you know what? I can do the width on this differently. Since we don't care about this, it's going to be 16 by 32. That's all I need. Okay, and I'm going to edit, copy, and then we're going to edit, paste. And that will be the Samus sprite. And let's just save this into okay. Now we need to convert the image. 16 colors. And then let's just double check the palette. Perfect. And let's save it. Then we want to export it as raw data. We'll load Samus for now. Yeah, I think I can rearrange the palette. Its colors, rearrange color map, and let's move the clear color to color 0, and we'll say OK. That puts the white up front because the white is the background. And I could make the background black. Let's undo that. And let's just take the background. That's the foreground color. We'll make the background color black. don't look very black. That's why. Samus don't need purple. You know what? Let's just use the white. We'll rearrange the color map back to white, and we'll click OK. Then we will save it. Then we will export it. Actually, we can just export the Samus data right there. And that should take care of the palette. Export it again. Where does that export? Turrican Acid Sprites. Turrican Acid Sprites. It's not 752, it's 759. unless it had no changes. Okay. Okay, let's convert this thing. And we're going to go to, and we'll leave that as hero sprite. Okay, there's the hero sprite. Now if we go to file names here, we're going to add we didn't convert the palette. Okay. Okay. So now we have so the base palette entry is at 1FA00, so that'll be palette 0. So if we look at the Commander X16 Veradocs, apologies for the cough, by the way. So if we take a look at the palette, which is down here, you'll see that there are 16 colors in each row. After the first 16 colors, it becomes shades and tints. Each palette has 2 entries, so we can use multiple palettes here for different things. So the main palette we're using for our level, which is the first 16 colors, so 0 through 16. The next set of palettes could be the it could be the sprite, a sprite palette. So we'll see that right now. So let's take a look. This is a test thing I was doing to try and port the Metroid code, and I did this in the Metroid code. So if we look here, I did a VRM palette 01, I did 1FA20 because the original is 1FA00. So the next logical one would be 20 because there are 16 palette entries. So let's set that and see if that works. So we'll copy this from this code, and I will set that in my here. And let's make it all align nice. And we will write this as hero palette. Okay. And that is where we're going to want to load the Samus palette into. So let us load the player into that palette. So we're going to need a new file. Okay, let's do that. So we're going to need to create two things. I want to get the level loading code out of the main executable here. And being that we're naming everything the same, I should be able, you know what? We'll have to figure out how to do that a little better, but I think we can do it. And we'll have to work on that. But for now, let's just make a level loading, a level code thing here. What do we want each level? Yeah, let's do that. No, I don't want. So we'll make a level.asm. We'll do this. And we're going to do level logic. Okay. And we'll do the include guards here. Okay. Alright, so we need to load the level, and in order to load the level, we got to know what level we're loading. So if we look at what we're doing here, we need to load the palette. We need to load the tiles, then we need to load the map. You know, I'm thinking this is better off. Here's what I think. I think each level is going to need its own logic and its own AI, and because we're on a 6502, we don't have the luxury of a scripting language like Lua or something like that. I mean, we could probably do something like Matt did with XCI, but it's too, I think it's overkill for Turrican. But each level is going to have its own logic. There are some that are going to be Um, and I'm just thinking out loud here. There's some that are going to be some enemies that are just going to do one thing. So we can program the enemies themselves with their own logic, but the levels in the background, if they have anything moving, if they have a timer for something or things like that, we're going to need to have its own logic. So my thought here is that we have a level take function. So if we did a segment BSS here and I did a level tick FN, and we'll reserve 2 bytes for that. And then we'll do a level load FN and reserve 2 bytes for that. And these are going to be like sort of like C callbacks. So for each level they'll have a load, a tick function, which is going to run every frame. And I don't think we need an unload. I think we just need a load. And I think, yeah, that should be good enough. So I'm trying to figure out how we're going to do .6502 is so restrictive. I shouldn't say that. It's just me who doesn't know how to use it very well. So there are people that have done ingenious things with it, 8-bit guy being one of them. Alright, so let's do, so we got a level load function, a level take function. Do we need that to be here? And I think if we did that, we're going to have to separate everything out. Should we call it load or init? Let's call it init. Level load, level init function. So we want to switch to level. We got to set all of the init function, the tick function, and then call them. So in order to set this, what I'm thinking here, I don't think we even need this file. So I don't think we need that file. Let's get rid of it. I think we can do this right in the main. And if we go down to the bottom here and we put the segment BSS in here, and then we can do level init FN, and we'll reserve 2, and then we'll do level tick FN, and we'll reserve 2 for that. Alright, good. And then we will do, we'll set the level codes individually. So if we do like level 1-1 ASM, Okay. Alright, and then we'll do L1. I don't know if it, yeah, it's not going to like the dash. So we'll do level 1 underscore 1 in it. And then let's take all of this, cut it from there, and put it in here. And then what we could do is we can load 16, which is our macro to load a 16-bit value into memory. And we want to load 16. And if we look at that, we need the destination to go first and the value to go second. So the destination being the init function. And we'll call this level 1 init. And then we'll do the same thing for the tick function. And we'll call this level 1 underscore 1 underscore tick. So that's how we're starting. And then what we can do with this is we can actually make the title screen like a level. So when we're ready to do a title screen, we could do that. So when we're done here, we have the IRQ. I think we need to stop all the IRQs before we do this. I think we need to stop all the IRQs before we do this. Yeah, because we need to be able to set the main. And this will be the starting point for the level. So this should actually go on level initialization as well. Oh, and I better RTS from here. I bet RTS from there. Okay. And then let's do level. And for now we're going to RTS out of here. I'm going to have to think of a way to do change levels and stuff, and point it to the right ones. Okay, so that should take care of that, and then of course we're going to need to do a dot include down here, and level 1-1-1 ASM. Okay, these were some test print strings I was doing to make sure I had the right thing. I don't need this anymore, so we'll get rid of that. Clean up the code a bit. So we have video in an IRQ, and if we want to load the map, so there is a bug in the 6502 where you can't RTS to you can't call a function from memory address. It doesn't call it back correctly. I think it's a bug, or it may be designed that way. Somebody correct me if I'm wrong, please. But as far as I know, what I have to do is I actually have to push the address on stack to return to before I do, and then I have to add a no-op after it so that it actually returns to that spot and then moves to the next line. The program counter moves to the next line. So if I wanted to call, let's say, the level 1 init function right here, I would have to LDA. Well, actually, what I would have to do is I would need to create a thing. So I would have to create a at level load, so level init, done. Or, you know what, our level init RTS, and then set this to no op right here. And then here I would have to load A, and I would have to load that address, the low byte of that address, with a high byte first, because I'm pushing it on the stack. Level init RTS, and I have to push it onto the stack. Then I have to load A again with the low byte. And push that on the stack. Then instead of calling JSR, I got to actually jump to it. So if I did level init function, then I actually jump to the function. Now, I'm pretty sure that should work. And then if we want to set, we have to do the same thing in the main loop. So basically in the main loop we got to call the game logic. So we want to check input, we want to check the joy status, and then we want to call the init logic, which, so we can do this. Copy it down here. And that is going to be and then we need to reset these at the bottom. Okay. Alright, so let's see if I should by all rights get, oh, this is way off. I should by all rights get the same thing I got before. So let's try it out. Alright, we got an unexpected trailing garbage character, level 1 ASM, line 7. Damn it. Alright. It looks like CA65 or CL65 doesn't like dashes when they have numbers after them. So we'll have to use underscores. Let's see if it works. Oop, I got a panic. Why did I get a panic? So let's find out. F12 this thing. So let's load the, this is where the output comes in handy. So we're looking at level init RTS, which is at address 836. So if we go here and I go to disassemble 836, there's the no op. Okay, so let's go to 82D and let's check out. Let's go to 82B. Disassemble 82B, and this is where so looking at this 82D, loading A, where's the load A? Now let's load 819. Alright, that's the load 16s. And then if we do level init RTS, let's find out what the address of that is. So we included that way down here. So here's the level 1_1_init. The address for that should be 946. Ah, damn it. I see what I did wrong. No. I did it right. Oh, okay, I didn't put that there. I took it out. Okay. So by all rights, we should be putting 4609 into that register. So looking here, load 16 level init function. And let's make sure the macro is correct. Load 16 goes destination, so I'm loading the oh man. No, that's right. Low byted eval goes into dest. High byted eval goes into dest. High byted eval goes into dest. Low byted eval goes into dest +1. So if we look at it, yeah, that's right. So looking at the breakdown here, I really wish this debugger was better. Box 16 I heard is pretty good, but it's not. I don't think it's mature enough yet. It's the question. So looking here, I am jumping, loading all this. Then we're loading 08. So 82D, we're loading 0836. I don't think it likes having segments in. So let's do this. I think this should work. let's try this and let's take this segment out. So this way it has everything that it needs in one spot. And that worked. So there we go. I had the same thing. So taking out the BSS segment from the video ASM seemed to have worked. So if I check out the address here, yeah, it's different. So we got 0944. So if I go here and I go here and we disassemble and head to 082D, oops, disassemble 082D. Alright, yep, that's right, 0836, yep, perfect. Then it's calling the, right here you see the jump to 09999. So if we look at the tick function, 9999 is here. We're jumping to that. And if we jump to that, that's grabbing the address out of that, which should be, if we look at memory, 0999, it is 0994, which is the start of the tick function. So that's correct. And it loaded, as you can see, it loaded everything, so that means it actually loaded it generically. Perfect. So now we have a way of switching levels and having levels have their own logic, which is fantastic. Alright, so now let's do, we got a half hour, so let's do some player loading, get that sprite in, and so let's see here, let's do a file, we'll call it player.asm. I'm sorry, I didn't even realize that. I'm so used to working in my own resolution, I forget that other people are watching. I have to get used to the streaming thing. Okay, so obviously the first thing you want to do is initialize the player. So we'll do player init, and we'll follow naming convention we use it everywhere else. So we're going to have a player init function. We're going to have a player tick function. And I'm sure we'll have others. We're going to have probably like jump, fire, move. That would be a good one. So let's start with init. So the first thing we want to do is load the sprite. So if we look in here, we didn't set a VRAM location for our sprites. So let's do that. So the tiles we're setting at 1600 here. And we said that the tiles are $26K. So if we do that in bytes, so if we do 26 times 1024, you get 26,000 bytes. Okay, so that is in hex. Let's do that again. We said it was 26K times 1024, so that's 6,800 in bytes. So if we do VRAM tiles here, and we're at 16,000, we can add and we get 1C800. Which is almost at the end of RAM. And the sprite file is only 1K, so we should be good there. I don't even think it's 1K, to be honest with you. I think it's less than that. So looking at this, it's no, it can't be 68K. Let's go here. Sprite file. It's 258 bytes. So yeah, we have plenty of room for one single sprite. We're going to probably have to move it later, but we'll figure that out. We'll rearrange the RAM here. So I'm saving room for the, in case you want to use a layer 1 on a tile map. So let's do this. So we want to be at 1C801 is where we want to be. So we're going to say VRAM layer sprite. Or actually, since we call it hero everywhere else, let's call it hero sprite. $1C801. I have a feeling it's got to be 800. Or 802 actually. It has to be aligned that way. So let's take a look at that. 1C802. Okay. Let's try that. Okay. So essentially we want to do the same thing that we did for the disk loading code. We want to load the palette. Alright, we don't want this to be VRAM palette. We want this to be VRAM palette 01. We're not loading this. We want to load the hero sprite. And that is the name we used, right? Hero sprite FAL-FN. Yeah, okay. Okay, and then the magical disk load into VRAM function. That should load the palette. So let's put this up here. Load hero palette. And then we want to load Samus sprite. So we're going to load the hero sprite. Let's not call it Samus, it's a hero. Okay, and then that we want to be essentially the same thing, except VRAM palette, we want to load VRAM hero sprite. And this should be hero sprite file name end, hero sprite file name. And that should take care of loading the sprite. there are going to be times we're going to need a few variables here. So let's set up some zero-page variables for this. So let's do this. Let's create the section. We're going to call it zero-page variables. Okay, so so far we have 40. Let's put everything in number order so it's a little easier for me to understand anyway. I don't know if anybody cares for that. vsync flag. Okay, and we're going to do, let's think here, hero direction. So we'll store that in, let's get into the X16 here and make sure we didn't add anything in here that is at the 0 page. So our last 0 page argument is going to be 36, which is why we started at 40. And I think that's it. So let's take a look here again. And instead of the hero direction, let's think of where we want to put this. I'm thinking all the hero variables, let's put the hero variables in the 70 range. So direction hero is facing, so we'll make 0 right and 1 left. Okay. Now we're going to have to find out what the hero's position is in the world. So that is going to be a 16-bit variable. So hero map pos x, or just hero position x. So we'll make this a 16-bit variable, x position in world, hero pos y, and then we'll say 16 bits, and then we'll say 8 bits. Okay, that takes care of the world position. Now, we're going to need Turrican to we're going to need a screen position for Turrican. So screen coordinates are different from world coordinates. So world coordinates on the map, basically moving around video memory. That would be, we're going to keep track of it with the top left corner of the sprite, I think. And that's where we're going to basically base our camera, quote-unquote camera, on. So I think we should take the screen separate, because if I think there's a little delay when you run to the right or you run to the left, and you I think the scrolling delays something like 20 pixels when you run to the right or you run to the left, and jump up and down as well. So I'm thinking maybe we track the screen position separately so that we can do that. So if we did hero, so then we're going to need, this should be map pos, or maybe world pos. So let's do WRL. do screen pause. I think this should be 8 bits. I don't, yeah, because you can only go, it's 320 by 240 the screen, but we're never going to go past the middle of the screen. So half of 320 is 160, so that's 8 bits rather. Half of 240 is 120, so that's, again, even 240 itself is 8 bits. So we're never going to go past that. So let's do that. We got to make sure that we leave room for the upper byte of the world pause. So we got to start at 76 for this. So screen X position on screen. Okay, I think that should be it. And now also we're going to need the camera, but I don't think we need to go that far just yet. I think we'll just keep it static for now, and we'll see what we get with this. Okay. Okay. I think that looks good. Alright, and then we need to initialize all of this. So initialize player variables. So I'm thinking the player position . So let's do this in, let me see if I can do OneNote. So let's see if I can draw with OneNote here. So we're going to have a screen. The screen is going to be 320 by 240. This is the player sprite. We want to be, so if the world is here, we want the player sprite to be right here at all times. Player sprite is 16 by 32. Excuse my horrible writing here. Player sprite 16 by 32. So to calculate that, we need to be at half the height. Half the width. So that's 16, but minus half the sprite width. So it's 160 minus 8 is where we need to be at all times when on the ground. We're not jumping, we'll say. For the height, 240, we're going to have to figure out where the ground plane is here. So we always want that person in the middle of the screen. So 240, half of that's 120. and then we have to subtract 16 from 120. So if we do 120 minus 16, we get 104. So if we do 160 minus 8, we get 152. So we're looking at 152 by 104. So this corner equals 152 by 104. Like a kid. Alright, so this corner is 0, 0. This corner is 320, 240. Yep. Alright, so that's how it's going to work. So now the scroll, we'll figure that out later, one thing at a time. Let's get Samus into the middle of the screen. Although we won't be using Samus. But either way, the sprite will be 16 by 32, so it should work for anything. So we need to be at 152 by 104. So let's work on that. So we want to store 0 for the direction. So hero direction. We want the player to start facing right. Right, and then we want an LDA 152 because that's where we said we want our X position in. And this is going to be hero screen X. Okay, yeah, that works. And then we're going to store that into hero screen pause X. And then we're going to go to 104. And this will be the hero screen Y. Okay. Okay. And then we got to we need an index for the Samus sprite. Well, index for the hero sprite. So let's make that a constant. And we'll do a sprite IDX hero. And that'll be 0. I think. Do we want the mouse? You know what, let's do one. We'll leave it just in case I want a mouse. Or something in there. We need sprite ID 0 for the mouse. Okay. So if we remember in one of our last episodes we made a bunch of macros and some functions. Here so let's utilize them, starting with setting the index. So here is initialize player sprite. and we're going to call sprite set attribute index and VRAM. No, this is going to be sprite IDX hero. Okay, then we're going to set the address to VRAM sprites. That would be the first frame if I did that. So let's start with the 0th frame. Okay, and then we need to treat our X and Y address as 16 bits. So we'll use our load 16 to load our position in. Now we want to know 152 is 98 in hex. So 104 is 68 in hex. What is 176? Possibly. Let's see. 104 is probably better. 68. Okay. So what we need to do is we need to load 16, utilize our macro again, and we're going to load ZPArg1, because if we look at our sprite thing here, ZPArg1 is the sprite X address. And then we're going to load that with our X value, which is 152, so it is 98. So if we go back here, 98 hex is 152. Then we're going to load ZPArg2 with our sprite, which was 68. Yep, 68. Good. And then we're going to call our sprite set position function. And this will set the position of the sprites on the screen. It's not VRAM sprites, I don't think. I think VRAM hero sprite I did this time. And then this is set sprite position on screen. And then let's set our, we have to set the Z level of the sprite. So that we want this to be in between level 0 and 1 for the time being. I think so we set a bunch of stuff up here, some constants. Oh, we didn't do the sprite constants yet. Interesting. Oh, let's do those now. So, looking at the Commander X16 documentation for sprites, so the mode, we're going to need 8 pixels, 8 by 32, so sprite width 8. The mode will be 4 or 8. So if we do, let me think here. So if we do sprite 4 BPP, that has to be set So the mode is all the way here at bit 7, so that needs to be shifted left 7. Now this will be 0. Sprite 8 BPB will be 1 bit shift 7. You know what, I followed the rules over there, so let me do that. 0 bit shift 7, even though it's not going to do anything. It's calculated at compile time anyway. So now we need to do the width and height. So if we look here, the width and height, 0, so 0, 1, 2, 3 being 8, 16, 32, 64. Oh wow, we could do 64 by 64 sprites. Forgot about that. So let's do, oh, and also that needs to be bit shifted. So width needs to be bit shifted 4, height needs to be bit shifted 6. Okay, so let's do that. So sprite width, eight. Okay, so now the other flags here, we're going to need to know whether the sprite is disabled between, so this is the Z depth field, which is right here. So in order to get that, we're going to need to bit shift 2. So we need to do 0, 1, 2, 3, bit shift 2. Okay, so let's do sprite I think that makes sense. So the sprite goes between the background and layer 0. I'll have to come up with something better for that. Swipe between L1 and layer 0. You know what? Let's do L0. And then we want the sprite to be in above L1. I think that should work. So, and then we want to do the horizontal flip and the vertical flip. So the horizontal flip, if we look at the sprite, it should, the first bit, so it's either a 1 or a 0. So what we'll do here is if we're going to flip it, it should be 1. And if we want to do this, actually, it should be 1, and we should bit shift it 1, which is technically 2. But since we're doing everything else this way, and then we're going to bit shift it nothing, so just so that we're consistent. Although we didn't do that here. You know what? Let's just do this. Yeah, that works. So 1, if we look at 1 in binary, it's the end. If we look at 2 in binary, it's the second one. So we don't have to do any bit shifting there, we just pick 1 or 2. Okay, and I think that's all. I'm wondering if we should do the joystick buttons while we're here. So let's check the joystick buttons while we're here. Is that in I/O? It is not. Let's check kernel. Right, there's the mouse. Ah, here it is. Okay, so AXY it comes back with. Alright, so A, B, X, and Y are bit shift 7, bit shift 6. So let's do that while we're here. So looking at this, A and B are at 7. So I'm just going to work like this in columns. It is a lot easier. I'm going to do joy button X. No, joy button Y. Let's do first. Just so I'm staying in the columns. 6. And then this will be X. And then we want to see, so at 5 we got select and the L button. Okay, so if we do joy, oops. If we go back here and we go to 4, that's start and R. And then we want to look at, I think this is, so this is not mapped. They're all should return 1. So up, down, left, right. Is this left trigger, right trigger, or is that left and right? Huh, that's interesting. Only one way to find out. So we're going to just label it as is. So labeling it as is LTRT. So I'm going to joy button up. Joy button down. I'm just going to label it LT. Nope, LT. Okay. All right, I think that should be, yeah, that should be enough constants to work with right now. So if we go back here, now what we can do is we want to tell it we want the sprite to be in sprite. We want it to be in L1. I'm going to set the Z level of the sprite. Now keep in mind, up here we're setting Vera to the sprite index address, and the index, if we look at the macro, it sets the increment to 1. So you see 1FC00, it's going to set the increment to 1 here. So we want to make sure that we get this correct. Let's make sure we get it correct. We got to set the stride to 1 here. So let's do that. Okay. All right, and then over here we're setting the address for the sprite. So when we set the address, it's actually incrementing Vera twice, because the first 2 fields in the sprite, if we look at the in the docs here, we're going to have to go back to the Vera. So the first 2, one is the address low, address high, address, and then we got to set the mode, which we want for BPP, so we don't really need to set it. It's 0. So it's going to be low address, high address on here, which is what we're setting right over here. This is probably a bad macro, only because we probably want to be able to set the mode on it as well eventually to make it a little bit more generic. Although we're not worried about that for this, we're using 0. But if we want to make this a little bit more portable so that we can reuse this file in the future, you probably want to set the mode independently. We'll worry about that later. It'll be on the list of things to do. But this is going to increment Vera twice. So incrementing Vera twice, 1, 2, will bring us to the X position. So then if we look at the X position here, and that's what we're doing, we're setting the X position. So if we go to the sprite set X position, here's increment 1, 2, 3, 4. So we're incrementing 1, 2, 3, 4. So then we're going to come down here to collision mask at this point, and we're telling it the Z depth we want to be at level 1, and then we're incrementing Vera again. So now that we're incrementing Vera again, we're on line 7 here, which is the final line of that sprite, the attributes for that, the hero sprite. So that's where we want to set the height, the width, and the palette offset. So the sprite height we said was 32, and the width was 16. So we want to LDA, and we want to do sprite height 32, or that with sprite width 16, and then the palette offset. We're going to have to set a constant for the palette offset. So let's do that. Let's go to here. And world should always be 0, but just in case we want to do something different. So we're going to set that to 0 this time, and the palette offset for the hero is going to be 1. Okay, I think that should be good. And then we're going to do the final increment on here, and that should be our player. Okay, let's see. So we need to include the player code. Now I'm putting it above the levels because the levels will use the player. So we got to make sure that the levels can access the player code, and if it's afterwards, it won't be really able to do that. So let's keep that before it. And we're going to init the player, and we're going to tick the player. So if we go to Turrican ASM here, after we load the level, we're done here. Then we want to JSR player init. And in the main loop, we want to execute the level logic first, or do we want to execute the player? You know what? Let's player tick. Let's update the player. Okay, so by all rights, we should see a Samus sprite on the screen. Alright, so let's see what we got here. Unexpected trailing garbage characters, player ASM 50. Player ASM 50, this thing, the set attribute index. Why is there trailing garbage? Because it doesn't need that. Okay. Symbol level 1_1 tick is undefined, ASM 27. Wait, why did that go undefined? It's right there. Did I screw up something? Ah, duh. That's what the in-glue guards are for. There we go. We should see Samus on the screen. Whoa, that was a crash. keeps going into the other screen. Alright, so that was a crash, and I'm not entirely sure why, because it literally crashed the whole emulator. Alright, whew. So let's take a look at the macro here. If the stride Why are you crashing? Works. Why are you crashing? Alright, let's see. How big is the level? $33K. So if we go to properties here, it's 32,770 in bytes. So if we look at, so 32,770 is where it would be. That's 8,002. So if we switch the memory, let's try switching the memory because that's pretty close to the end of RAM. So let's see, where were we? So if we set 8,002, let's set this to 08004. Right, yeah, 08004 should be good. And let's see if that works. I hate that. Okay. A little weird. It's a little offset in the memory. Could that be because I set the RAM wrong? No, VRAM Hero Sprite. So that is weird, man. It's like getting in between the frame. Okay. Oh, it's I went a half hour over here. This is weird. Alright, so we got something else we need to fix. However, the screen position is wrong. For the ground, that is. You want this thing to be on the ground, and that could be the scroll position as well. So we're not exactly correct. So we want this to be the center of the character. Should be moving around. All right, I will. All right, let's call this a night because I'm kind of late already. So it does compile. It does do everything. So let's check in code. All right, we're going to check in the Samus asset. Let's delete all these other ones that we don't need. So let's go back here. We don't need this. Actually, this, yeah, I do. We don't need this. Let's go here. Alright, so the one that we ended up using was just Samus, so let's get rid of Turrican Hero. We don't need this. Don't need this. This is useless. This is useless for now. Keep all the Samus stuff. Get rid of that. Okay, now if we go back to source control, that is a little bit more okay, that looks good. Yeah, we're going to delete it anyway. We will add these to git ignore. No compiled stuff in git ignore. And yeah, let's commit. So level loading logic and player sprite. And let's save it. Oops, save. And check it in. Save the changes. And there you go. Everything is checked in. Alright guys and gals, have a good night. And I will see you next Tuesday.